Let's recap what we learned. Voltage can be thought of as a pressure, while current is analogous to a flow. Well, a flow of what? Remember that electricity is the
presence and flow
of electrical charge. Electrical charge results from the negatively charged electron, which you may have seen represented like this, or this. In each diagram, a net positively charged nucleus is surrounded by a cloud of negatively charged electrons. Electricity is simply the manipulation of these electrons when they are free and can travel from one atom to the next, just like Bill Nye's example of bees traveling from one beehive to the next. This net movement of bees, or electrons, is called current. It's electron flow. No, not flow. Flow. So how do we manipulate electrons? How do we make them flow? It's all about conversion of energy. You all have learned about kinetic and potential energy, right? Let's do a brief recap of energy for our purposes. Take a look at the following video. Now let's rewind and break down the physics of the video. First, Wiley climbs back to the top of the cliff. He exerted kinetic energy on his body to climb up the cliff, and the energy is now stored in his height. Then Roadrunner thinks it would be funny to release that energy, so he bumps Wiley off the cliff, and the energy Wiley worked so hard to store is now released in kinetic energy as he falls faster and faster to the bottom of the valley. Ouch. So to translate that analogy to electricity, we can think of a battery as containing a bunch of electrons on a cliff. The electrons have potential energy to do work. Then, when you plug a battery into a flashlight, the electrons fall down the cliff and their potential energy is converted into work. This potential energy is referred to as electric potential. As stated before, electron flow is called current and is measured in coulombs per second, or amps. This is a rate just like miles per hour or gallons per minute. A coulomb is 6.241 times 10 to the 18th electrons. If you measure a current of 1 amp, that means 6 million electrons are flowing by a single point in 1 second. That's a lot of electrons. Finally, we will be building many circuits this week. Remember that electrons must flow in a complete path, as shown in the schematics below. To the right are a few basic schematic symbols. Don't worry about memorizing these now, as you will see them all week and they will become very familiar to you. Next up, we will talk about computers. Unpack your very own Arduino and begin programming.